Hey everyone, welcome back. In this video, we're going to benchmark Brotli and see how it performs against our dataset. We collected data from 697 benchmarks, which took us over 60 hours to run. There's a lot to say, so let's get started. Brotli is a data compression algorithm developed by Google. It's aimed to be used for compressing HTTP content and improve website load times. It was initially developed in 2013 and the latest version is 1.1.0, released August 2023, which we are using here. For using Brotli, you have two choices, one static version and one dynamic version. We didn't find any difference between them for compression and decompression benchmarks, so we used the dynamic version. Unfortunately, Brotli cannot process directories. It only performs actions on single files, so we had to archive our benchmark folder into a single file before handing it out for processing. We used RAR in store mode because it delivered a near identical size to our dataset compared to zip and tar. Brotli has 12 levels of compression quality, ranging from 0 to 11. And on each level, you can define the window size ranging from 10 to 30. Note that window sizes over 24 are not compatible with Brotli standard and may not be decodable with regular Brotli decoders. But we are testing it to see if the higher values of window sizes, however incompatible, can provide better or faster compression. Let's start with level 0. Space saving starts with 11%, gradually increasing to 19.94%, with window size set to 19. After that, we don't see any improvement. I think we hit the limits of what level 0 can do. Compression times are very fast, most around 3 seconds, but in some occasions a bit slower at 6 to 7 seconds. From window size 10 to 12 though, there seems to be something that makes them very much slower compared to others, but mostly on compression side. They are 57 to 140 megabytes per second, while others are 250 plus and reaching up to 550 megabytes per second. On efficiency, we reach a highest score of 6 at window size 18, and others are scoring good too, ignoring the first few mentioned. By increasing the compression level to 1, the maximum compression reaches 20.47%, and this time at window size 19. Compression time and speed still has unexpected results at first, but then, just like level 0, most at around 3 seconds, and processing speeds also show the same pattern. But on the efficiency chart, level 1 reaches new highs. With window size at 29, it scores 6.54. That's a new high for efficiency. Moving to level 2, our minimum and maximum space saving raises to 15 and 22.18%. This time reaching its max at window size 23. Compression time is now tame, some hiccups here and there, but most are around 7 seconds, and that's double compared to level 1. This means compression speeds are halved and they now hover around 220 megabytes per second. Therefore, our efficiency score drops too. We now can barely pass the score of 3. In level 2, the most efficient is window size 17. With level 3, again a slight bump overall, now maxing at 22.76% at window size 27. A 1 second increase in compression time for all, a bit slower speed, and as expected, less efficient than the previous level. Now the maximum efficiency is at 2.53 with window size 24. On level 4, maximum compression is 25.17% at window size 27. Still, the higher window sizes aren't showing any difference. Compression time is a bit more expected now. Lower window sizes perform faster than higher ones here. Except window size 18, which is the longest at 30 seconds. Compression times are now below 100 megabytes per second, but decompression seems still high and not much affected by increasing compression level. Efficiency drops again, and now our best result is at window size 17 with 1.53 score. Level 5 adds 1% to all window sizes space saving. 26.61% is the maximum at window size 27. Two bumps are visible here, one from 16 to 17 and one from 24 to 25. Compression times start at 16 seconds and go up to 40 seconds, resulting in decreasing processing speed for compression. The compression speeds are still independent from compression speeds and behave differently. We see a drop of efficiency in level 5, capped at 1.22 with window size 13. Level 6 compression results are nearly identical to level 5, a minor boost overall, but takes much more time to deliver it and makes it way slower than level 5. It just makes it less efficient overall. Level 7 is the same story. Improves the compression by a tiny bit while making considerably longer time to process. Still, it's amazing to see the decompression speed is intact and high up as usual. Efficiency is heard more again and we barely passed the score of 1. Level 8 is also a minor step, maxing at 27.69%. Still, the window size of 27 to 30 seem to not deliver any difference. Processing times for higher window sizes are now doubled at around 300 seconds or 5 minutes, and processing speeds are now as low as 5 megabytes per second. Efficiency is more or less the same as before, except the higher window sizes, they are halved compared to level 7. Level 9 is barely touching 17% of space saving at its minimum and 28.17% at maximum. Compression time now reach as high as 20 minutes. Decompression speeds seem to be affected now. We don't go over 400 megabytes per second anymore, and most are around 250 to 350 megabytes per second. Compression speeds are at lowest, with 1.4 megabytes per second for window size 30. We don't see efficiency to touch 1. Here our max is 0.73 and most other are below 0.5. Level 10 now is a bit different than others. It improves the space saving by 1%, which is way better than past 4 levels. And at window size 29, maxes with 29.34%. But not so happy. Compression times are also way different. We don't see under 1 minute results for lower window sizes anymore. In fact, our lowest time here is around 17 minutes, and we hit an hour with window size 30. It's a bit odd though, as we expected to see the lowest time to be for the smallest window size. Yet here, window size 18 is the fastest. Compression speed can't pass 2 megabytes per second, and decompression speeds are also decreased from 350 megabytes per second to now around 260. That dip in compression time, along with the increasing space saving, made this peak in efficiency. However, the score of 0.02 is barely anything against 6.5 from level 1. And last, the level 11 is another small improvement to space saving, maxing at 29.60%. Compression times are way worse, starting at around 50 minutes and reaching up to 86 minutes. That's nearly a football match to watch, and let's not talk about speeds. Max at 600 kilobytes per second. Still, decompression seems to not care about and hovers around 250 megabytes per second. Efficiency is not the aim for level 11. It doesn't even try to get a 0.01 score. All are below that. Now let's compare the space saving and efficiency at all window sizes in each level. For space saving, level 11 at window size 29 beats all at 29.60%. Level 10 with the same window size is just 0.26% behind. But level 9 with window size 30 has a much larger gap, around 1.17%, lower than level 10. In efficiency, Level 1 with Windows size 29 is a king, with the score of 6.54. Level 0 with Windows size of 18 at 6 is half a point behind, and in Level 2 with Windows size 17, we got a score of 3.11. That was so much data. Now, how does Brotli perform compared to other three we had benchmarked before? ZPAQ, UHARC, and Vim. Let's check it out. In space saving, Brotli sits between ZPAQ and UHARC, with level 11 at Windows size 29. It delivered a 29.60% space saving, a 0.55% lower than ZPAQ. But in efficiency, Brotli really shines. It topped our chart with a score of 6.54. Compared to others at 1.64 and 1.14, it's a huge win for Brotli. And the current king of efficiency is Brotli at level 1 with Windows size at 29. That's it for this video. Thank you for watching. Comment down your suggestions and thoughts down below, and we will see you next time.